Supernova. Nova. Can't stop. Hyper. Stellar.
We hear a lot about supernovas in pop culture, but what really is a supernova? There are different types of supernovae depending on the types of stars involved. Type 1a, 1b, and 1c supernovae are interesting because their spectra lacks or has little hydrogen, a key component of stars. Type 1a supernovae involve a white dwarf in a binary system, and these happen only about every 500 years in our galaxy. In these types of binary systems, the white dwarf star steals matter from its companion, and eventually when the white dwarf star reaches a mass around 1.44 times more than the sun and implodes, leaving no remains of the white dwarf star. Type 1b and 1c supernovae occur when a large star dies and its core collapses. However, the large star has already shed its outer layers late in life. A type 1b supernova involves a star that has shed its outer hydrogen layer, but a type 1c supernova not only sheds its hydrogen layer but also helium, leading to neither of the two gases being seen in the spectra. Type 2 supernovae, similar to type 1b and 1c, involve a large star's death. In a type 2 supernova, the atoms that fuse together to make heavier elements in the star's core make the star heavier, and eventually it can't support its own weight anymore. It collapses under its own gravity and explodes outwards, releasing a ton of energy. In type 2 supernovae, we can see hydrogen on the spectra, and a type 2 supernovae leaves behind a neutron star. You might remember in the day 1 video, I added this caption here. This is because supernovae are like the universe's way of recycling. In the cores of large stars, heavy elements are made, and when the star explodes, those heavier elements get dispersed out into the universe, as well as other vital elements like carbon and hydrogen. The spread of these materials into outer space allows for new stars to be made and allows availability for elements that are necessary for life. I guess we really are all made of star stuff.